Hi, I'm Laurel. Today I'm going to present a counting concept, which is counting path. And I will go through this concept with a classic question. And here is an n times n grid. And the question asks us to go from the bottom left corner to the top right corner. And we have to make sure the path is the shortest and all the steps are the same, just they have the different directions. And because we need to make sure the path is the shortest, so we cannot go backward, which means we can only go up and go right. So we have n step, upper step, and n step to go right. So we have totally n plus n steps. Really basic question. And then we go to the second problem. How many paths of this length are there? So we can go up first or go right first, which means we can make some arrangement of those steps. And all the upper steps are the same, or the right step are the same. So what we need to do, choose n place from n plus n, which is equal to choose the steps go right, n from n plus n. And if we start with a northern step, which means we will reach this node, and the problem will become from this node to the top right corner. And now we have n minus 1 upper step and still n steps to go right. So what we need to do is choose n minus 1 from n minus 1 plus n, the total step, and which is equal to choose n from the total step. And then another situation, first go with an east step. We will reach this node, and similarly with the previous question, now we have n upper step and n minus 1 step to go right. So it will become choose n from n plus n minus 1, the total steps, which is equal to choose the steps go right, n minus 1, and from the total step, n plus n minus 1. And because if we start from the bottom left corner, we have two choices. We can go upper first or go right first. So which is these two situations. So if we add these two situations together, which should equal to start from the bottom left corner to the top right corner, and which is choose n from n plus n, the total step. And if we want to prove that, we first need to do the simplification. This one is n plus n factorial divided by n factorial times n factorial. And for this one, based on the formula, should be n plus do a little simplification and divided by n factorial times n minus 1 factorials plus a little simplification as well, n minus 1 factorial times n factorial. Because we need to add these two together, so we need to make these two the same. Hence, we decide to times another n, which will make this 2n factorial. And because we times n here, so it should be n times n plus n minus 1 factorial. And similar here, we times an m here. This part will become n factorial times n plus n minus 1 plus factorial. And these two added together will be n factorial times n factorial. And put this one in the front of the sum of n and n, which will become 2 n plus n factorial. And interesting things happened. These two are the same. So we do the proof successfully, and thank you.